Welcome to the Water Engineering channel. My name is Sohaib and I am a water treatment engineering. In this video, I am going to explain you what is a progressive cavity pump. You will learn also the classification of pumps and all the informations about the progressive cavity pump, like how it works and what are the advantages and disadvantages of this pump. Of pumps. Pumps are used in a wide range of industrial and residential applications. Pumping equipment is extremely diverse, varying in type, size, and materials of construction. The pump medium is usually liquid, however, many designs can handle solids in the forms of suspension, entrained or dissolved gas, paper pulp, mud, slurries, tars, and other exotic substances that, at least by appearance, do not resemble liquids. Pumps are divided into two fundamental types based on the manner in which they transmit energy to the pumped media: dynamic or positive displacement. In dynamic displacement, a centrifugal force of the rotating element, called an impeller, import velocity energy to the fluid, moving the fluid from pump suction to the discharge. On the other hand, positive displacement uses the reciprocating action of one or several pistons, or a squeezing action of meshing gears, lobes, or other moving bodies, to displace the fluid from one area into another. Positive displacement pumps are divided into two broad classifications: reciprocating and rotary pumps. For reciprocating pumps, the reciprocating action of the pump causes a plunger or piston or diaphragm to move back and forward, which in turn causes the liquid to flow into and out of the pump. For rotary pumps, liquid is drawn into suction nozzle through a set of gear and lobe. Here you can see an animation of how the liquid is pushed out through the discharge nozzle. Other used rotary pump types are screw, vane, and progressing cavity. In this video, we will discuss about the progressive cavity pump. The progressing cavity pump was invented as a supercharger for an airplane engine by Dr. René Moineau following World War I. Due to the multi-phase and high suction capability of the pump and its ability to convey large quantities of air, vapor, or gas in a fluid, which may also contain solids, this pump is not usually used in the same way or considered to be the same as other rotary positive displacement pumps. The progressing cavity pump was designed as a combination of a rotary pump and a piston pump. It represents an integration of the specific advantages of both types of pump constructions. Other terms for progressive cavity pumps are cavity pumps, prog cavity pumps, and PC pumps. Progressive cavity pumps are mostly used in wastewater treatment plant. It handle thickened and treated sludge transfer and polymer dosing. In petroleum production, the pump is used in cutting transfer, drilling, mud transfer and recovery, separator feed and crude oil transfer. In food and beverage applications, progressing cavity pumps can be designed to reduce the risk of contamination. The pump is also used in sewage, slurry and sludge pumping. In the paper and pulp industry, the pump is used in pulp transfer, recycled paper transfer and filler transfer. To understand how the pump works, we must start by knowing the pump parts. The pump is made of several different parts based on the type and the supplier of the pump. Here, I have covered the most important parts in a standard progressive cavity pump. You can see the different parts of the pump. I have framed the main components here. So let's start with the first part. The stator of the pump is designed and built in single block design. It is composed of a steel shell, which has a double helix profile inside made of rubber. The main elastomer types used in stator manufacturing are nitrile butadiene rubber, ethylene propylene diene monomer rubber, fluorocarbon and polytetrafluoroethylene are chosen in function of the abrasive media, chemically aggressive fluids and various working temperatures. The second component is the rotor. Depending on the work environment, they are made of annealed alloy carbon steel plated on the outside with 0.3 to 0.4 mm layer of hard chrome. For highly corrosive and aggressive environments, rotors are made of stainless steel, also plated with hard chrome on the outside. The third part is the shaft sealing. It is of mechanical sealer gland packing type and is permanently lubricated by the circulated fluid and chosen to withstand working conditions. The last part is the drive geared. It can be geared motors, variable speed drives or hydraulic motors of all major manufacturers, and it can be directly flanged to the pump without additional couplings or guards. Pumps are available with a variety of accessories to ensure suitability for your process. It can be equipped with dry run sensor, which prevents the dry running of stators through the use of a temperature probe, sensing when temperature of stator is over a set temperature and stopping the motor. The pump can also be equipped with a protection against over or under pressure. A diaphragm pressure gauge with open flange for highly viscous media switches as soon as the pressure drops below or exceeds the set value. Just like other positive displacement pumps, a progressive cavity pump is a flow-creating device. Let's take a look how it works. The pump draws the fluid via the suction inlet and transports it into an elongated casing. Inside the casing are housed a helical rotor and stator. As the rotor turns, it touches the surface of the stator, leading to small cavities formation. The fluid then flows progressively through these series of cavities until it is expelled via a discharge outlet. The pump moves the displaced fluid at a constant speed, regardless of the inlet pressure. An important consideration with progressive cavity pump stators is the geometry profile. Generally, there are 4 different stator geometry technologies in the marketplace. Different flow rate and pressure stability are achieved by varying the design, so choose the right stator, depending on the features of the fluid. There are many advantages to such pumps like wide fluid handling capabilities. Designs can handle viscous liquids, large solids, abrasive materials, fibrous solids and gas slugs without issue, making it one of the most versatile pumps available. This pump has unparalleled viscosity handling. Viscosities from 1 cst to 1 million means there are no comparable pumping technologies. Also, due to the tight tolerances in its construction, it has high suction capabilities, priming up to 8 meters with a corresponding low NPSH. And, due to flow being directly proportional to pump speed and due to its cavity design, it enables flows to be very predictable, enabling it to be used in metering and dosing applications. Another advantage is the pump can be operated in either direction, and the suction becomes the discharge and vice versa. The pump can also be operated vertically or horizontally depending on the installation. For the disadvantages of progressive cavity pump, running the pump dry is by far the biggest reason these pumps fail. So a fluid film is required to lubricate the contacting surfaces due to the interference fit between the stator and rotor. Low speed also requires variable frequency drives or gear reducers that add to the cost of the installation. Also, the low viscosity fluids tend to slip by the rotor to stator fits, and the pump will be less efficient. And with highly viscous fluids, there is a pump speed above which the fluid will not flow fast enough into the pump. When this occurs, the volumetric efficiency of the pump is compromised. The manufacturer of the pump can assist in determining the speed limits for a given fluid and viscosity. In a water treatment plant, these pumps are used for metering and dosing polymer. Here you can see the installation of the pump vertically or horizontally depending on available space. Here another picture of a progressive pump feeded by a decanter centrifuge. As you can see, progressive cavity pumps are an attractive option for a variety of reasons. Whether you are pumping food and drink products, viscous chemicals, or in need of a downhole directional drilling mud motor, this style of pump offers incredible efficiency.